Ever wondered how robots learn to pick up objects or open jars without being explicitly programmed for every step? It's not about writing millions of lines of code. It's about teaching them to see, understand, and act in real time. Today, we're diving into a groundbreaking approach called VITA, a system that transforms how robots learn from visual input. Let's unpack this innovation and see why it's a game changer for AI-driven robotics. Here's the challenge. Traditional robot learning systems often rely on methods like diffusion models or flow matching. These techniques work by starting with random noise and iteratively refining it into a target. Think of it as solving a puzzle by guessing pieces one by one. But this process is slow, computationally heavy, and prone to errors. It's like asking a robot to find a needle in a haystack by randomly poking around, hoping to stumble on the right spot. Enter VITA, a smarter, more efficient framework that rethinks how robots process visual data. Instead of brute-forcing solutions, VITA uses latent visual representations, which act like compressed mental maps. When a robot sees an object, VITA converts that image into a simplified numerical code, a 512-dimensional vector, if you will. This code isn't a messy sketch. It's a streamlined roadmap that captures the essential features of the scene. It's like giving the robot a GPS instead of a torn-up map, letting it navigate complex tasks with precision. Here's where VITA gets clever. It bridges two distinct worlds. Visual data is high-dimensional and full of details, while robot actions are sparse and sequential. To connect them, VITA creates a structured action latent space, a compressed representation of movements that mirrors the complexity of the visual input. Imagine translating a 500-page novel into a single tweet. The core ideas stay, but the noise is stripped away. This allows the robot to plan actions based on what it sees, without getting bogged down by irrelevant details. And here's the technical punch. VITA uses multi-layer perceptrons, MLPs, simple neural networks, instead of resource-heavy architectures like transformers. This design choice slashes computational overhead. In experiments, VITA reduced inference time by 50% to 130% compared to existing systems. On the Aloha platform, it mastered tasks like opening jars or assembling parts, both in simulations and real-world settings. It's the first MLP-only system to handle such complex multi-step actions, proving that simplicity can be powerful. What does this mean for the future? VITA isn't just faster, it's a blueprint for scalable, adaptable robotics. Imagine self-driving cars that react to sudden obstacles in milliseconds, surgical robots that adjust to tissue variations on the fly, or factory assistants that learn new tasks without reprogramming. By eliminating unnecessary complexity, VITA makes robotics more efficient, reliable, and ready for the messy, dynamic real world. So the next time you see a robot performing a task smoothly, consider the invisible engine behind it, like VITA. Thanks for watching. If you want to explore more on AI's role in robotics, hit subscribe. And drop a comment. What robot task would you love to see mastered next? Until next time, keep exploring the frontier of intelligent machines.